and welcome back. In the previous video, we created this yaw delta member variable on the shooter anim instance. And we saw that when we're turning, this yaw delta becomes positive when we're turning right, and it becomes negative when we're turning left. And if we move very rapidly left or right, then it maxes out at -90 and +90. Now we're ready to add some leaning animations to our running blend space that will use this yaw delta. So let's get started. Now here in the _game folder in character and animations, let's take a look at our running blend space. So double click running blend space and we'll see that we've created a 2D blend space, but we're only using the horizontal axis. And this blend space will blend between strafing and running forward. And of course, at the very outer edges, we have ourselves running backward. Now, in the lean direction, the vertical axis, we called this axis lean, and we're going to set the minimum and maximum axis values here. Let's go ahead and set these, and we're going to use -90 for the minimum and +90 for the maximum. Now, what animations are we going to use here? Well, we saw that when we're turning to the right, then our yaw delta variable value starts to go positive and it maxes out at 90. So we're going to want a leaning right function. Now I'm going to hold Alt and left click and drag just to move our view around to the back so we can see behind our Bellica character here. And that way we can see whether she's leaning to the right or to the left. Now let's take a look at the animations we have in our asset browser. Now, if we click on Search Assets and type in Circle, then you'll see that we've got all these jog animations that have circle in them, and they all say either circle left or circle right. Now, these are leaning animations. Now, take a look at jog forward, circle right. Let's go ahead and double click on this, and you'll see that it looks like she's leaning to the right. So this is what we're going to use for jogging forward when our yaw delta is 90. So go ahead and close out of that and open up running blend space again, and we're going to type in circle, and I'm going to use jog forward, circle right, and I'm going to put that in the middle at the very top for our value for 90. And if we hold shift and we drag our mouse up, you'll see that she starts leaning to the right. And again, I'll hold Alt and drag so that we can see that she's leaning to the right here. Now, we're going to use jog forward, circle left, and we're going to drag that down onto the bottom, and that will be for a yaw delta value of -90. So we can hold shift and drag our mouse down, and you'll see that now it looks like she's leaning to the left. So you can see that this is altering her lean value when she's jogging forward. Now we have some jog right, circle left, and jog right, circle right animations. We're going to use those for when she's strafing to the right. So let's go ahead and use jog right, circle left, and put that at the bottom. And that's right here where our lean value is -90 and our offset value here, offset yaw, is 90. So that's our jog right, circle left. We're going to use jog right, circle right, and put that up here at the top, where offset yaw is +90 and lean is +90. Now we can hold shift and we can see that this will cause us to lean, and we can actually rotate our view around to the side here and see that it's making her lean based on that offset value. So here's a good angle. You can see as we're moving our mouse down, she's sort of leaning backward a bit, and as we're moving our mouse up, it's more of an action in her shoulder there. So let's go ahead and do our jog left animations. We'll do jog left, circle left. That will be down here where offset yaw is -90 and lean is -90. We also have jog left, circle right. That'll be up here where offset yaw is -90 and lean is +90. And finally, we have our jog backward, circle left and right animations. Now these are going to be on the right and left sides of our blend space. Jog backward, circle left will be on the bottom, so we'll put that at the bottom on the very right and at the bottom on the very left. And then jog backward, circle right will be up at the top right and at the top left. So this makes our blend space truly two-dimensional, and we will have our leaning animations based on our yaw delta value that we'll pass in here. So let's go ahead and save and close out of this and go back into our animation blueprint. So in _game character, let's double click on shooter anim BP. Now let's go all the way back up to our ground locomotion state machine. And here we have our run state, and if we double click on that, you'll see that we've got our running blend space. Now we have a lean value we can pass in, so right click and type yaw delta, and we'll get yaw delta and we'll pass that in, and now we can compile and save this, and let's go ahead and test play this and see how it works. I'm going to go ahead and go to Window, Viewports, and Viewport 2 so we can have a full screen available to us. So I'll go ahead and start running, and I'll lean to the left, and it looks like she's leaning, but it looked like I had a jerk there. Yeah, it looks like it's jerking the animation a bit. So we'll need to take a look at why that's happening. We can also strafe to the right and lean, and you'll see that we have a bit of a lean when she's strafing to the right. Let's try strafing to the left, and it looks like we get a lean when we're rotating there. And let's try moving backward, and we have our lean when moving backward. Okay, so it's looking good except for that jerkiness. We had a bit of some jerkiness when we started playing that animation, so let's see what is causing that. Okay, so we can figure out what's happening with our jerkiness to our animation by inserting a debug message. So let's go back to Visual Studio, and here where we're adding an on-screen debug message in our lean function to print yaw delta, let's add another message here, and instead of yaw delta, let's print character yaw. So I'm going to take character yaw, and I'm going to replace it in the formatted string and also pass that in as the value. So if we compile this, then back here in the editor we can playtest. And here we have our character yaw being printed to the screen. Now let's start running, and let's look at our character yaw as we rotate up towards -180. And as we reach -180 and go past, then we switch to +180. So I'm going to start running, and I'm going to turn around, and you'll see that as the character yaw approaches -180 and goes past it, we jerk. And that's because character yaw is going from -180 to +180 instantly. And that's going to cause the sign of our yaw delta to change from negative to positive very rapidly. So this is a problem, and we need to fix it. Now here's one way we can fix it. Here we're back in our lean function, and you can see that our character yaw last frame and character yaw, these are both float values. Now if we instead work with rotators, then we can get the difference between two rotators without having to worry about sign differences. Now here's what we're going to do. Let's go to our .h file, and instead of character yaw, we're going to save our character rotation as an F rotator. So F rotator, and instead of character yaw, we're going to call this character rotation. And for character yaw last frame, we're going to instead use F rotator, and we're going to call this character rotation last frame. Now back in shooter anim instance, we're going to take our character yaw last frame and replace that with character rotation last frame. So this will say character rotation last frame, and it's going to be equal to character rotation. And character rotation will be set equal to shooter character get actor rotation. So we won't be getting the yaw. Now let's make an F rotator called delta. And let's initialize this, and we're going to use a function from Kismet Math Library. Kismet Math Library, and this function is called normalized delta rotator. Normalized delta rotator takes two rotators. We're going to use character rotation and character rotation last frame. Okay, and of course this delta can be const. So this is a const F rotator called delta, and we're initializing it with normalized delta rotator from Kismet Math Library, and we're taking the delta between the rotation last frame and this frame. Now all we need to do is take target And instead of taking the difference between what we had before, which were two floats, now we can take this delta and get its yaw. So now what we're doing is we're taking our rotation and our rotation last frame and using this uKismetMath library function to get a normalized delta rotator. And this is going to handle any sign changes. This is going to take two rotators which have a world orientation rotation, take their delta, and we'll get a actual rotator that represents the change in rotation. This is going to be independent of whether or not our world rotation changes signs. And then we're simply getting the yaw from that. And one last thing we need to do, since we've changed these variables to f rotators and we no longer have our character yaw and character yaw last frame, we're going to initialize these up in the constructor and we're going to remove character yaw and character yaw last frame. So the variables we have now are called character rotation and character rotation last frame. So let's go ahead and replace these. So character rotation, and this will be initialized with an F rotator with 0 passed in. That'll be a 0 rotator. And this will be character rotation last frame. And this will also be initialized to a 0 rotator. Now our other variables we had called TIP character yaw and TIP character yaw last frame, we can go ahead and give those default values of 0. So let's put those right after character rotation and rotation last frame. So this is TIP character yaw, give that a default value of 0, and TIP character yaw last frame. We'll give that a default value of 0 as well. And finally, we also added a yaw delta variable. Let's go ahead and initialize that to 0. Okay, now before we compile, let's go all the way down to the bottom of our lean function. And you'll see that we used character yaw in our add-on screen debug message. But now we already know what character yaw is, so we really don't need these debug messages. So what we can print instead is our delta yaw value. So let's go ahead and print delta.yaw. And let's go ahead and change the string to say delta.yaw. And we'll go ahead and compile this. Okay, we're back in the editor. Let's go ahead and start running and see about leaning. And notice as we're running that delta.yaw value is simply just giving us a delta. It doesn't matter whether the character's rotation flips from -180 to +180. That normalized delta rotator function from KismetMath library takes care of that. And so now we have her leaning as she's running. And this actually looks a whole lot better than it did before, because when she's just running upright, it doesn't look very natural. Now we have a nice lean. Let's go ahead and start strafing and see about leaning while strafing. And that's looking pretty good. Let's strafe to the left. And she leans backward and forward depending on whether she's turning while strafing left or right. Let's go ahead and run backward. And that looks pretty good. As we're leaning, she leans, and you can really see her shoulders leaning in one direction or another. So this is starting to look really good. Okay, so that will conclude this video. We have implemented leaning successfully. So now she has turning in place, she has in place aim offsets, she has leaning while she's running. This is starting to look really dynamic and really nice. We're going to continue adding more and more animation capabilities, so stay tuned.